Hey guys, welcome to day 37 of 100 Days of Code. Today we're going to be learning about advanced authentication methods using the header, and we're also going to be learning how to make post, put, and delete requests using the requests module. And once we've learned all of that, we're going to be building a habit tracker. This lady is Simone Gertz, and she's somebody who I really admire. She makes all sorts of useless robots, that's what she says, but they're actually really fascinating. And one of the products that she brought out through Kickstarter was this habit tracker, where you could go to it every day and just tap on today's date. So if you wanted to meditate every day, or if you wanted to read 500 pages of a book every day, then you could track your habit. And because it's continuous, it makes you really want to continue your streak and not break the line. So we're going to be using technology to build a digital version of that today. And we're going to be using an API called Pixella. This comes from a Japanese developer, and it's really awesome. It allows you to track your habits, but not just show which days you've done your habit, which days you haven't, but it also shows the intensity. So, for example, maybe you want to track how many pages you're reading every day. You want to build a reading habit. Well, you can see that on certain days, you're really reading a lot and you're hitting a streak, but then on other days, even though you are doing some reading, because the color is lighter, it means that you read fewer pages. And over a year's time, you can see your entire progress and you can see your habit being tracked day by day, which I think is really awesome. This is what we're going to end up building. You can take any example or any habit you want to build. So in my case, I want to try and cycle every day, and I'm logging how much I'm cycling in terms of kilometers. And you can see that certain days I cycled a lot and other days I've cycled a little bit less. But I can see which days I've missed out on cycling and try to keep up with the momentum and the streak. Maybe you want to keep track of how long you're spending every day learning to code. Or maybe you want to track how long you're meditating every day. Or maybe you want to track how many lengths in the pool you swam. Whatever habit it is you're trying to build, I'm sure that by the end of today's project, you're going to have a tool that's going to help you achieve your goals. So once you're ready, let's get started by heading over to the next lesson. We've been using the requests module for a while now, and we've been using it to make HTTP requests across the internet. We've already seen the GET request, and this is a way for us to get pieces of data from somebody else, like an API provider. Now, there's also 4 other common types of requests that we should probably know about: post, put, and delete. We can use the request module to complete a GET request by simply writing requests.get, and then we put our parameters inside the parentheses. For the other 3 requests, the code looks pretty much the same. It's .post, .put, and .delete. Whereas a GET request is made where we ask an external system for a particular piece of data and they give that to us in the response, a POST request is where we give the external system some piece of data. And we're not so interested in the response we're getting back other than whether if it was successful or not. For example, if you wanted to save a piece of data in Google Sheets, then you might use the Google Sheets API to post your data into your Google Sheet. Or maybe you want to use the Twitter API to post a tweet. Then your program is going to send your tweet through a post request to the Twitter API. So that's how GET and POST works. Put is where you simply update a piece of data in the external service. So if you had a spreadsheet in Google Sheets, then maybe you want to update some of the values in the spreadsheet. Then you would use a put request. And finally, delete is simply where you want to delete a piece of data in the external service, like a tweet that you posted or a Facebook post. Today, we're going to be building our habit tracker using the Pixella API. And in order to use this API, we're going to post our habit tracking data. For example, how many pages of a book we've read, how many kilometers we've cycled, and we're going to be posting that data to Pixella to be tracked in our graph. If you head over to their website and you scroll down, you can see that it tells you how to get started. And it's a series of 6 steps. So we're going to be completing these in order, and we're going to be pairing this short form Get Started guide with their documentation. So we're going to have that side by side in order to see all of the documentation on each of the steps. Step 1 involves creating a user account. And it says you have to hit up this particular endpoint using the HTTP post request. So this is the first time we're making a post request. Now I've set up a new project in PyCharm called Habit Tracker, and in my main.py, as always, I'm going to start off by importing the requests module. Now because this is a brand new project, we're going to have to install that package to make this red underline go away. And once it's been installed successfully, we can tap into that method requests.post. What are we going to put into this parentheses? What are the parameters? What are the inputs? Well, the first thing is the URL endpoint, right? So this is the Pixella endpoint, and that is going to be all of this. Let's copy that over and paste it in as a string. Now, if we head over to the API document, you can see that there's an index of the API on the right and also at the beginning of the docs. So what we want to do is first create a user. That's step 1. Now, this API is actually really well documented, especially given the fact that it's actually not a big development team behind this. If we take a look, this is the endpoint, and this is what we've got in our code. Next, we're going to make our post request, and we're going to add some parameters into the request body. So you can see that some of these are required and others are optional. So we're going to add a value for each of the required parameters: token, username, agreed terms of service, and that we're not a minor. So let's create our user params, and the first key is our token. Now let's see what this token needs to be. It has to be a string that's used to authenticate your user. And we're going to use it later on as well when we access our graph and when we add to it. So make sure you save this securely. This is basically like an API key that you're going to generate yourself. This token can contain any characters, so you can make up a key like this, but the length of the token has to be between 8 characters and 128 characters. So I think I've definitely got more than 8 characters there. So I can move on to the next key, which is my username. I'm going to try and see if I can get away with just my first name. If it fails, we can always try again. Next, we've got agree terms of service. And this is going to be either yes or no. We're probably going to have to say yes if we actually want to use this service. And also we're going to have to say yes that we're not a minor. Let's make sure that we don't make any typos by simply pasting this in. So it's a yes for agree to terms of service and a yes to the fact that I'm not a minor, sadly. Not a minor anymore. Once we've got our user parameters and our Pixella endpoint, then we're ready to make our post request. Again, we're going to start off with the URL, which is going to be our Pixella endpoint. And then we're going to add a new keyword argument. And this is called JSON. Notice how all the data that we're posting over to Pixella is pretty much in the format of a JSON, string and string. This is basically a piece of JSON data that we're going to send over. And that's all there is to it. The endpoint and also the JSON data that we want to send over. So let's go ahead and save this inside a response variable, just as we did before. And then once this is completed, let's go ahead and print what the response is. Now you can either tap into the response as a JSON, but given that in this case, we're not really looking to do anything with the response, we just want to check if it's actually successful or not, we can actually tap into a property called text. So it'll give you back the response as a piece of text. Let's go ahead and run this and see if I can get away with setting my username as Angela. Wow, So there's actually no user called Angela at the moment, and I was able to nab that username. So the reason why we're interested in looking at the response is if there were some issues. For example, if I try to run this again, now that I've taken this username, I think it's probably going to fail, and it tells us this user already exists. Now, alternatively, if we said no to one of these, agree to terms of service or not minor, it's probably also going to give us a message telling us why this post request failed. But now that I've completed this step, I can actually comment it out because I've now created my user. We've now set up ourselves with a new account on Pixella with a username and also a secret token that we're going to use in the future to access this account. It's effectively our username and password. So in the next lesson, we're going to create our graph and we're going to learn how to use a more secure method of authentication. So for all of that and more, I'll see you on the next lesson. Previously, we completed step 1, which is setting up a user account on Pixella. Now we can move on to step 2, which is to create a new graph on Pixella for our username. So notice how the endpoint is now different, because in addition to /v1/users, we also have to add our username now, and then /graphs. So let's go back to the documentation and scroll down to the relevant part of the API, which is this part, to create a graph. That's step 2. This is also going to be a HTTP post request, but the endpoint has now changed. So let's go ahead and create our new endpoint, which is the graph endpoint. And this is going to be comprised of the Pixella endpoint, and then in addition, it's going to be / our username. So let's take out our username and our token and put it as a constant at the top. Now we can add that in here using an F string. And then finally, it's / graphs. Now remember, if you're doing this along with me, this username is going to have to be your own unique username, and the token is going to be your own secret token. Once we've created our graph endpoint, the next step is to make our post request. Again, we're going to use our request module and call the post method to make this request. This time, what is the data that we want to send over? Well, we want to be able to add the ID of our new graph, so some way of identifying it in the URL, and then the name of the graph, and then the unit of measure that we're keeping track of. For example, if I'm keeping track of my cycling, then that's going to be kilometers that I've cycled. Or if I want to keep track of how long I'm coding, then that might be minutes or hours. And then the data type of the unit of measure. If I was tracking the number of pages I've read, then there'll be whole numbers. If I'm tracking the number of kilometers I've ridden, then it's probably going to be a floating point number. And then finally, we're going to specify the color of our graph. Here you have to be a little bit careful because these are strings which are actually in Japanese. So for example, Momiji is autumn leaves, Shibufu is grass, Sora is sky, and they've got a whole bunch of poetic names for each of these colors, which is wonderful, but it's also prone to errors. So you have to be careful when you're typing in the color that you want. And if in doubt, just simply copy it from the documentation. So let's go ahead and create our graph configuration. To start off, I have to specify an ID. And in this case, it has to start off with some letters from A to Z, and then it could be letters or numbers. And it has to be between 1 and 16 characters. Let's say that the ID of my graph is going to be graph 1. Notice how we can't have the number at the beginning because of these rules. Next is the name of the graph. So mine is going to be my cycling graph. And then it's the unit of measure. So because I'm tracking my cycling, it's going to be in kilometers. And then it's going to be the type of data that I'm going to be posting in this unit. Because it's kilometers, I'm probably going to have some numbers after the decimal point. So I'm going to keep it as a float rather than an int. And finally, we're going to pick a color. I'm going to pick purple ajicite, which is a hydrangea flower. And just to make sure I don't make a mistake, I'm going to copy that and paste it in. That's all of my required graph config. But right now, if I do the same thing as I did before, which is to put in my graph endpoint as the URL, and then the JSON is set to equal the graph config. If I actually post this right now, it's not going to work. And if I print the response.text, you'll see the reason. The message tells me that the user Angela does not exist. I know it exists because I created in this step and I got a successful response. Or it's telling me that the token is wrong. So think about it. Where have we actually provided our password? Where have we provided our token in this request? Nowhere. It's not one of the request body keys. So how do we provide our authentication? Well, it's done using the request header. We have to provide this key and it's going to look for the token that we used to register with Pixella. You might have even noticed previously when we were working with the news API that when we were looking at the authentication, even though there's 3 methods for authentication via a API key query string parameter, which is what we used, or via the XAPI key HTTP header, or via the authorization HTTP header. And you can see that they actually say we strongly recommend either of the latter two. So using the HTTP header. And the reason is so that your API key isn't visible to others in logs or if they're doing request sniffing. So what exactly are these headers anyways? Well, if you think about a letter that you might get in the mail, the header is the part that contains some relevant pieces of information like the phone number of the company or the website of the company or their logo. And then the body is the actual message part, essentially. It's the part that changes from letter to letter. Now, back in the previous project where we created our stock news alert application, you can see that we're simply sending our API key as a parameter along with the GET request. And what this effectively looks like if we're doing it in the browser is we're taking the news endpoint, we're putting it into the URL bar, and then we're adding our parameters. So the first one is the API key. And then the next one is the actual query. So we were querying for the company name in the title of the news piece, and we were looking for Tesla. This is effectively exactly the same as our code here. We make a request to that URL and pass over these parameters. There's effectively no difference between this and that. As you can imagine, all our secret stuff is in the request itself. So if anybody's monitoring this, then they'll be able to see all of this information and they might be able to steal your API key. Now, one of the things that's reassuring is that this API is accessed via HTTPS, and the S stands for secure. So this request is actually encrypted. But it doesn't stop somebody from installing something on your browser to look at what requests you're making. And there are certain cases where this might leak your API key to somebody that you don't want to. So for some API providers, you'll see that they want you to provide the authentication in the header. Let's go ahead and do that. So let's take the key that they're expecting, and let's create a dictionary called headers. And let's make that the key. And then the value is going to be our token. So this is our top secret password. Now, in addition to our URL and the JSON that we're sending over to Pixella, we're also going to add an optional keyword argument, which is called headers. This is not going to show up when you start typing, not like JSON or URL. And this is because it's one of the QARGs or keyword arguments. And that means you also have to spell it exactly right and make sure you don't make any typos. It's headers with an S at the end. And then we're going to pass our variable headers into this parameter. Now we're going to make our request once more. And you can see this time when we print the response.txt, it gives us success. And we've now managed to set up our brand new cycling graph. So if we go back to step 3, we can actually go ahead and look at our cycling graph by going to this URL and replacing this part, which is the creator's username, with our own. So mine was Angela, yours will be something else. And we're also going to replace this final part with our ID, which in my case is just graph1. Now we're going to finally tag on an .html to the end, and when I hit enter, you'll see it go to my brand new cycling graph right here. And it's going to be colored in purple, and it's going to look beautiful, and it's going to start tracking my cycling data. So this is how we can authenticate ourselves using a header. And the request module makes passing over headers just as easy as passing over other parameters or other parts of the message body. In the next lesson, we're going to be moving on to step 4 so that we can finally add a pixel of data to our graph. So head over to the next lesson and give that a go. So we're now finally ready to move on to the last step, which is posting a value to our graph. And this is going to create a new pixel on our habit graph. So I want you to pull up the relevant piece of documentation, which is going to be posting a pixel. And I want you to take a look at the description and the header and the body and see if you can complete this step as a challenge. Notice that firstly, the endpoint is again different, and everything that's inside these angle brackets need to be replaced with your actual values, so your actual username and your actual graph ID. In addition, this is again going to be a post request, and it requires the authentication in the request header. Finally, you have to provide the date in the format of 4 characters for the year, 2 characters for the month, and 2 characters for the day. So today would be 2020-07-24 in this format. And then you have to provide the quantity that you want to add to today's pixel. So if you cycled 10.5 kilometers, then it would be 10.5. If you originally set up your graph to track integers, for example, the number of pages you've read in a book, then that would be the number. So I want you to pause the video and see if you can complete this step as a challenge. Have a go now. All right, so the first thing we're going to do is to update our endpoint. I'm going to comment out this previous step because we've already created our graph, and we're now going to move on to our pixel creation. So that's what I'm going to call my endpoint. Now, this pixel creation endpoint is obviously not what we need. We need to format this URL so that we add in the first part, which is the Pixella endpoint, which goes up to /users. So that's all of this part. So we can use an F string and add the Pixella endpoint. And then we're going to replace the /username with our own username. And then it's /graphs. And we have to replace this graph ID as well. And in my case, the graph ID is simply just graph1. So it might make sense to create a constant for that as well. So that we can use it at the very end of this endpoint. So now that we've created our endpoint, the next step is to create the request body. So passing over the date and the quantity. So I'm going to create the pixel data, and this is going to first have the date, but it has to be formatted in the way they specified. So 4 characters for the year, which is 2020, and then 2 characters for the month, 07, and then 2 characters for the day. But notice here that they specify the data type for the date has to be a string. So we can't simply leave it as a number. Instead, we have to add some quotation marks around it. And then finally, we can add the actual data, which is going to go under the key quantity. And this is also going to be a string, and this is the quantity that we're going to register in the pixel, and that's going to determine the intensity of the actual pixel. So in my case, I did actually go for a quick ride today, and my stats were not fantastic, but I'm still going to log it. So that was 9.74 kilometers that I cycled. So that's what my quantity is going to be, 9.74. And again, this is a string because that's what the documentation tells us. And remember that when you set up your graph, if you set up the data type to receive floats, then you can actually give it a floating point number. If you set it up as int, then you have to give it a whole number. Now that we've got our data and our endpoint, then we're finally ready to create our request. So request.post, and again, our URL is going to be this new pixel creation endpoint. Our JSON that we're going to pass over is our pixel data. And finally, we're going to reuse the headers that we had from previously because it still contains the same token that we need to authenticate ourselves. So let's see what is the response that we get back. So I'm going to print out the response.txt, and hopefully if everything went well, then we should get the success message. But now is the most exciting part. We can go back to our cycling graph and then hit refresh, and we should see our brand new pixel show up in our graph right there. And it tells us today we cycled 9.74 kilometers. One thing you might be wondering is, well, how can we get this date to be automated? Because I don't want to have to check the date and type it in. We can use the date time module, right? So in the next lesson, I'm going to show you how you can use a method called stringftime in order to format the date time that you get from Python into any format that you require. For all of that and more, I'll see you on the next lesson. In the previous lesson, we saw how we could create a pixel, but one of the things that would be nice is instead of having to type this manually, I would really like to be able to create that using the datetime module. I can import my datetime. So from datetime module, I'm going to import the datetime class. And now I can use it to get today's date by tapping into datetime.now. But if I print this out, you can see that this is clearly not going to be in the format that I need it to be. So I'm going to comment out my request, and I'm going to take a look at what my data looks like. This contains the date and time, and it's in a different format. So whenever we encounter a new API or a new service, they often want the date and time in a different format. For example, in Asia, the year tends to come first. In the US or in the UK, the year tends to come at the end. How can we format the Python date to any format we need? Well, there's a really useful method called the stringftime method. And this allows us to pass in a string that will format the date that we get back from datetime into any format we need. For example, if we pass in %A, then we'll get the short version of the weekday. If we pass in %B, then we'll get the full name of the month, and so on and so forth. So we can use this table to actually create the exact date format we need. Let's go ahead and take this today, and let's go ahead and use the stringftime, and we're going to pass in a string. Now, the first string we need is the year in the full version. So this is going to be %y, and it's a capital Y. Now, if you need a dash, then you can add a dash. If you need a space, then you can add a space. But in my case, I actually want it all together. So the next thing I want is the month as a number. So that's %m, and then it's %d to get the day of the month. Now, if I actually print this out, you can see that this is formatted in the exact format I need. And if I want to add in a, asterisk there, then it will format it like that. If I want to change the date to a word like Wednesday or December, then I can simply change that format string. Now that we've managed to do this, then we can get our date time programmatically using the datetime.now method. We can also use it to create any date time of our choosing. So let's say I wanted to backtrack to create a pixel for yesterday. Well, then I can simply create my date time by specifying the year, the month, and the day. So today's 24th, so yesterday was 23rd. And then it's going to take that date and it's going to format it into the correct format and then post a quantity. So let's say that yesterday I did cycle a bit more actually. Let's say it was 15 kilometers. Now, if I go ahead and uncomment this and run it again, it's going to post the latest piece of data to Pixella. And if we now update our graph, you can see I've now got 2 pixels, and this one is a lot heavier in terms of color to show that I cycled a lot further than today. And we've now got a total kilometer, a max, a min, an average, and the total number of pixels. The last thing I want to show you before we finish off with this project is how we can update and delete pixels using the put and delete requests. That's what we're going to do in the next lesson. Now, in the very beginning of today's lessons, I mentioned that we can do other requests in addition to get and post, like put and delete. And we can do that using a similar format as we have done for get and post. Just by simply changing the method, we end up with a different behavior. So put will change an existing piece of data and delete will delete the piece of data. Let's try it out for size. If we go into the documentation and we scroll down to all the things that we can do to pixels, you can see we can also update a pixel, which is put, and delete a pixel. So let's click on update first. And let's say that I decided that yesterday I didn't actually cycle 15 kilometers. I lied, I only cycled 4. Well, how would we do that? Well, we would use the documentation here and also the put method to achieve this. So I want you to give it a go and see if you can figure it out. Now, I've already told you that you need to use the put method, and you know how to format the endpoints and provide the request body and the header. So pause the video and give this challenge a go. All right, so the first thing we're going to do is to copy this new format of the endpoint. And I'm going to comment out the previous part where we posted our pixel. And I'm going to create this new endpoint. So this is the update endpoint. And it's going to be a combination of everything up to here, which is our Pixella endpoint. And then it's your own username. And then it's graphs, and then the graph ID. And finally, it's the year, month, and date for the piece of data that you actually want to update. So let's say that I'm going to update yesterday's piece of data, which I've manually created up here and I formatted using string ftime right here. So I'm going to replace this with a set of curly brackets and paste that in there. Now notice, because I've got these 2 sets of double quotes, it's getting a little bit confused. So I'm going to change one of those sets to a single quote instead. and now I get rid of all my errors and warnings. So this is our update endpoint, and the only thing that we're going to change is the quantity. Let's say I create a new pixel data dictionary, and now my quantity, instead of being 15 kilometers, was actually, let's say, 4.5. So this is my new pixel data, and now I'm ready to make my put request. So we're using requests.put, and then the URL is going to be the update endpoint. The JSON is going to be our new pixel data. And finally, the headers is going to be our headers for authentication. So now let's go ahead and run this code. And once we get our message success, we can go back to our chart, refresh it, and you'll see that yesterday's pixel no longer is as dense, and in fact it's now lost a bit of color and it's been updated with the new value. So finally we have our delete method, and we're going to use that to delete a pixel. Again, I want you to do this by yourself. See if you can delete one of the pixels in your graph using the endpoint and the documentation. All right, so the endpoint is identical to the update endpoint. So I'm simply just going to copy it and create a new one called delete. And I'm also going to comment out this request so that I use this one instead. Now, the delete endpoint doesn't actually take any data, but it does need the header. So we can use our request module and call the delete method and pass in the endpoint, which is the delete endpoint, the headers, which is our authentication headers, and we can already enact our request. Now when we hit run, if it gives us a success message, then we know that we've updated our data here, and we now no longer have 2 pixels, we only have 1 because we deleted the one for yesterday. That's all there is to it. If now you want to be able to track your habit, all you have to do is to comment out all of the rest of the responses and reactivate the one where we post our pixel data and changing the quantity into a custom input. So in my case, it'll be how many kilometers did you cycle today? And then of course, changing our date time back to now. And now when I run my code, it will go ahead and ask me how many kilometers I run. I could type in the number, and then when I hit enter, that data is going to be posted to the servers. Now, of course, because I already have a piece of data, this is not going to let me. So I'm going to have to wait for tomorrow to post my updated cycling data. I hope you enjoyed building this project together, and I hope you'll have a go at trying to modify this to your own habit tracking and see if you can do some creative stuff with it. And as always, if you create something fun, be sure to share it with the rest of us.